In example 2, we need to simplify the following expressions, just the same thing we did for example 1. So we're going to take that same approach, at least with this first one, and we're going to try to see if we can deal with this in terms of just cosine and sine. So I've got the cotangent here. The cotangent's cosine over sine. And then I've got the sine of x, and you could write it as over 1. You can, it doesn't really matter here. So the cosine times the cosine is cosine squared. And if I want to add these two fractions together, I need to have a common denominator. To do that, I'm going to multiply the numerator by sine of x and the denominator by sine of x. So that'll be sine squared up here. It's supposed to be an equal sign there. Now we can add these two fractions together. So we've got the cosine squared plus the sine squared. Cosine squared plus sine squared is 1. So we have 1 over the sine of x, and that is the cosecant of x. So this whole mess up here just simplifies down to the cosecant of x. When you get to calculus, it's a little bit more difficult to try to work with this type of expression, but if we can work with something that has the same value, then it might be simpler that way. And so part of this is to simplify these more complicated expressions and see if we can get something a little bit easier to work with. For part B, we already have sine and cosine, so we're kind of stuck in terms of turning everything into sine and cosine. So we've got to do something different. I'm noticing we have 1 over the cosine, and it is the cosine squared. And so we can use maybe a reciprocal relationship here, and the cosine and the secant are going to have a reciprocal relationship, and it does work. 1 over the cosine is the secant, or 1 over the cosine squared is the secant squared too. So then we have minus 1. If you take a look at your trigonometric identities toolkit, you'll notice that we're probably going to be dealing with this one here. Notice, and this is off to the side, so notice that we had 1 plus the tangent squared of theta equals the secant squared of theta. Let me move this back on. And if I just subtracted 1 from each side, I'd have the tangent squared equal to the secant squared minus 1. So we can replace this with the tangent squared. And then this time it's alpha here. The variable is just the variable. You could have also taken the secant squared out and substituted 1 plus the tangent squared. The 1 minus 1 would be 0, and you'd be left with the tangent squared. This is as simple as we can get. We're all finished with B. We're going to work with C and D here. And you'll notice that for C, we already have sine or cosine. We don't have anything else going on. So what we need to do is just try some things. And one thing that I think we could do here is distribute this, or FOIL it, or multiply these two together, however you want to think about it. So we've got 1 times 1, that's 1. 1 times the sine of B, that's the sine of B, and it should be actually beta, it's got a little tail there. Negative sine of beta times 1 is negative sine beta. And then a negative times a positive is a negative, and we've got sine squared. These will cancel, so we've got 1 minus sine squared. And if you look at your Pythagorean identities, we're looking right here at this sine squared. What we need is 1 minus sine squared. If we just had that, we might be able to do something with it. So let's see if we can adjust this one. Cosine squared theta plus, 2 plus signs, don't need that. Sine squared theta equals 1. We're going to adjust it by subtracting sine squared theta. So we've got the cosine squared theta equal to 1 minus the sine squared theta. Well, the variable is different, but that doesn't matter. 1 minus the sine squared is the cosine squared, and we'll use, of course, the variable we're given in the original. Not much you can do with this one. It's fully simplified. With the next one, you could start this one off by changing everything into sine and cosine. That would probably work. Let me give you maybe a more elegant solution to this one. What we can do, and what I'm seeing right now, is I'm seeing this 2 and 2, so we can probably factor one of those out. And then I've got 1 plus the tangent squared. And it's going to be really good for us over the secant squared. 1 plus the tangent squared is reminding me of something I saw in my toolkit. So 1 plus the tangent squared is the same as the secant squared. So we'll just substitute those for each other, or at least the secant squared for 1 plus the tangent squared. We are allowed to cancel these out. That's 1. So we're just left with 2. This probably would work if you just changed everything into sine and cosine. You might have a little bit of a mess on your hands. You could also do it, and hopefully you get to the same result at 2.